All right, so this is where we had left off with yesterday. Okay. So as far as naming these compounds, first thing you do is find what? The longest continuous or parent chain. Okay. Then next thing would be determine what the suffix is, because if it is saturated, that means it's an alkane. So then all of your carbons have what type of bonds between them? Single. Then if the suffix is ene, it's an alkene, and it's telling you what? Somewhere there is a what bond? Somewhere there's a double. And then finally, if it ends in yne, like this one, it's also unsaturated. So somewhere there's a what bond, if it's an alkyne. If it's an alkyne, somewhere there's a what bond? There's a triple bond located somewhere. That is correct. Okay, now, one of the aspects that this author goes to discuss is, they use common names. Neopentane is one of them, and what we would refer to that is 2,2-dimethylpropane. Okay, now that's an isomer of pentane. That's why it's called neopentane. But at our level, I think it's best for you to just list what the derivatives are and what is the simplest or easiest way to name what a derivative is. Like a methyl group. Why do we call that a derivative? Because it's derived from what? Methane. Okay? So an ethyl group, that is a derivative, and it is derived from what? An ethyl group is derived from ethane. That's correct. Okay, now, as we move forward, sometimes, maybe, if this wants to cooperate. But the laser's working. For some reason, this doesn't want to. Well, it's not cooperating, so we'll just do it this way. Okay? So in certain cases, okay, an aromatic compound means it's giving off an aroma. Okay? So it can give off a pleasant odor, or in this case, okay, sometimes we would say aspirin's not a pleasant taste, but yet, for the most part, a lot of these give off a pleasant aroma. Like wintergreen is one, and that's what your activity will involve next week. Okay, we just need a little more background information to be able to look at what the process is for making this smell or aroma called wintergreen. Maybe what? Well, probably not in the sense that you are referring to. That comes in a little plastic can. No. Yes, ma'am. So probably a lot of this wintergreen would be referred to chawing tobacco or chewing tobacco or whatever it is you want to refer to. Okay, but and again, what we'll be illustrating here is what benzene actually is. I don't have a whole lot. We're going to be discussing materials behind here that will help you. So I want to do this one, that one, and then that would be it. Okay? Now, a lot of the solvents that you would use in any type of shop, whether it's working on gasoline engines, working on diesel engines, you're probably going to have a solvent that would have this as its base structure, okay? And it used to be that benzene alone was utilized as a cleaning solvent because it had a very, very pleasant fragrance, but like many compounds can, if they are a carcinogen, does that mean anything to you? Probably not yet. You haven't learned it. A carcinogen would be an aspect or molecule, chemical that causes cancer, okay? And benzene would certainly do that. But again, it was a very, very good solvent for and utilized for many years. Okay, the last slide for today, and then we got some materials to look at behind the screen. Okay. And for those of you who move on to take the course Anatomy and Physiology, okay, when we talk about cholesterol, okay, that has a multitude or many fused rings to it, and cholesterol can be viewed as a steroid. And the body actually produces many of these steroids naturally, whether it is, of course, testosterone is one, estrogen's another, progesterone's another. Some of them are amino acid based. Some of them are, I got to think about this. Those are your more common ones. They're either composed of steroid hormones or non-steroids, which means if they're amino acid driven, insulin would be one, and that's produced by your pancreas, and glucagon would be another, but that's for another time or another place. Okay, so what I want to do is close this off. Does anyone have this information that wants it? Okay. So behind here, if you choose, you can write this down. I know it looks like a lot, but I need this for the general chemistry class. So this is what we're talking about right now. These are aromatic compounds, so I'll put them in this brown box here. Okay? 2 years.
Oh, 2 years. So we're learning 2 years stuff.
I didn't say that. I said you would be learning cholesterol and steroids in the future if you decide to take that class. Didn't say you're learning it now.
So why do we have to write it down?
These?
Yeah.
I said if you choose to, because these are different ways of writing the compound benzene. Okay? That's what all that means. Because the formula for that, as you can see, is 6 carbons and 6 hydrogens. Hello.
I need my coat.
So everywhere that these lines intersect, whether it's a ring structure or an aromatic type, These are carbon atoms, as you can see. So it's a six-sided figure. You could call this cyclohexene, or like we just wrapped up, you can call it benzene as well. Means the same thing. This is a way of writing benzene. This is another way. This is the most common. And what that circle inside this six-sided figure means is that there's alternating double bonds. That's all that means. This is probably the simplest way to write benzene. Most convenient, simplest, and probably makes the most sense. But to describe that, we thought it was worth our time to write this content down. Okay. I'm going to go ahead and erase this. So now, if you had to name this structure right here, okay, well, let's build upon what's actually there. If this was your compound right now, again, where these lines intersect, there is a carbon atom. Okay, so how many sides does this have? You can look at it that way, or you can count the number of carbons on there. Either one would be the same. So how many carbons are present? Okay. So what is the prefix for a 5-carbon compound? It's a geometrical shape as well. Okay. So we would have P, E, and T. Is this saturated? Yes, because everything's single bonded, correct? Okay. So what is the suffix for carbon-to-carbon atoms that are single bonded? It's saturated, so the suffix is YNE, ANE, or ENE? ANE, so we're getting closer. Now, this is a ring structure, so you would have to put what in front of it? We've talked about it, maybe say that again. Cyclo. This would be cyclopentane. Okay. Okay, there's just one more student that I want to catch because it's a ring structure. Caitlin. We handed this out today. All right. So do you want me to hold on to it till tomorrow? It's due Thursday.
Yeah, we'll do that.
Okay.
Thank
All right.
you.
Yep. Okay. If you had to draw pentane, okay, that means you're doing this. Okay? Okay, so what is the formula for this? We know you got 5 carbons, okay? How many hydrogens are on this compound? 12. There's one above, one below. 5 times 2 gives you 10. You count the ends. Okay? So the formula is C5H12. Okay? When you count the carbons here, since it's pentane, we know that that's 5, but how many hydrogens are located on this compound? Hydrogens. There's a hydrogen, there's a hydrogen, there's 10, okay? Since this is a ring structure, this only has 10 hydrogens. A straight chain like this has got 12 because it's not a ring structure. You lose 2 bonds when you change it to a ring structure. That's how you know that it is cyclopentane. And if it's cyclopropane, okay, what would that mean to you? Cyclo means what type of structure? Okay, a ring structure. Propane, how many carbons is that? Okay, so a ring structure with 3 carbons would be this. That is cyclopropane. Got 3 carbons, 6 hydrogens, and it's a ring structure. So therefore, it is cyclopropane. Okay. What about if you have 4 sides to it? Or if you want to make hydrogen atoms like that or like this, these are all hydrogen atoms. These are carbon atoms. So how many carbons do you have? What's the prefix for 4? Okay. And it's a ring structure. So what do you put in front of that? Cyclobutane. Okay. So left, outside, middle. Are we good? Okay. Middle. Are we good? Right side. All right. Does everyone have this content that one? Because if we're nodding our head yes, I'm under the perception that you understand this, which is great. Okay, now we had this on here and we had this on here. Okay? So remember, this was cyclopentane when these were just hydrogen atoms. Okay? But this is a derivative. So is this one. The formula for CH3 does not give you methane, but rather gives you what instead? Methyl. Okay? So, anytime, like Jack over in Madison and Taylor over in Madison playing golf. So what is the goal when you're playing golf? To get the lowest what? Okay? And maybe for it not to rain too, but get the lowest possible score. So what that means, you want these 2 derivatives to have the lowest possible number. It doesn't always mean that you're going to stop, that you're not going to start up here. You can start here, or you can start there. So you tell me, this one or this one? So top or bottom? Top or bottom? Okay? So when you do that, you're assigning this as number 1, carbon number 1. Okay? Carbon number 1 is not up here, because if we did that, going in this direction, this methyl group is on carbon what now? It's on carbon 2, because we've got 5 of them around here, remember? So this one is carbon number 1, and therefore this one's carbon number 2, this one's carbon number what? 3. Now, the reason we got to go in a specific order is if we go the other direction, we say this one's carbon number 1, carbon number 2, carbon number 3, then this would be carbon number what? 4, correct? Okay. Do we follow this? You want the lowest possible number. Okay? So that's why you don't start with number 1 up here. You start where that derivative is. That's why we said top or bottom. You had picked the top one. This is carbon number 1. And you go around till you hit carbon number 3. Okay? The hard part's done now. Okay? So your derivatives are on which 2 carbon atoms? Number 1 and number 3. So we've got 1, 3. And what derivatives are these? Okay? So we can go backwards. We can reverse engineer this. Okay? What is this telling you right here, ANE? What does that tell you? Everything's single bonded, okay? What does PENT tell you? How many carbons there are, okay? What does cyclo tell you? That it's a ring structure, okay? So I'll just do that. What does a methyl group mean? What's the formula for a methyl group? CH3. That's what this is telling you, okay? What does di mean? That there's two of them. And then what do these two numbers tell you then? Where they're located on the first and third carbon. Okay? If you are doing well in understanding this, you are well on your way to being successful. And if you don't, please say something. Find an upperclassman, they can help you, because if you are struggling with this, we want to point you into the right direction. Okay, can we erase this? Okay. Okay. So this orange one, this is the last two things that we'll do, and then we'll get you on your way. What are you going to do first with this? Find what? Well, maybe I should let you write it down first. My apologies. And if you decide to choose in and watch this, yeah, I understand there's glares on the whiteboard, so you may want to consult with your classmates to get a better idea of what that might say. So what is the first thing that you're going to do with this compound? You're going to count the carbons. That's right, because when you do that, you're right, but what does that mean when you count your carbons? You're finding what? The what chain? You're finding the parent chain. That's right. So upon doing that, what is your parent chain, do you think? Okay, so when we do that, that must be 7, right? So we'll just see once how we go. 1, 2, 3, 4, 5, 6, 7. Okay? Maybe that is, well, what happens if it branches the other way? 1, 2, 3, 4, 5, 6. So it cannot go up and over because there's only 6 carbons that way. Plus, you wouldn't know what to name this. So that means this carbon compound goes left to right or right to left. But you correctly said heptane. Why does it end in ANE? Everything is single bonded. Okay? So is there anything branching off of that heptane? Yes. Okay? So what is this called here? Remember, this is a carbon-to-carbon bond, so we'll put it in a box. Okay? And if this helps you, put an M by here, because that M means methyl. Okay, you can do that. And then what is this derivative called? This is an ethyl group. Okay? So when you're looking at this, you can say, I'm talking about M and E, or me. It doesn't happen very often. But now, how do you assign the lowest possible number? How can you read these carbons? They can go right to left, or how else can they go? Okay, so you pick one. Left to right or right to left? Okay, so the question or the answer was right to left, or excuse me, left to right. So this methyl group is located on which carbon? Okay? This ethyl group is located on which carbon? Okay? But we need to determine, maybe we're going right to left. If we do that, 1, 2, 3, 4, that's still on the same one. But what happens if we get over to this one? That's on the 6th. Okay? So is this a better combination? Or is this a better combination? Which one's lower? The top one. Okay? So what that means then, the last thing you need to do is put these in alphabetical order. Okay? So upon doing that, okay, alphabetical order, what comes first, ethyl or methyl? Okay? Now, I understand the number is bigger, but E for ethyl comes before M for methyl. So therefore, what you need to do is start with 4 is where that derivative is located. And what is this derivative called now? When you put that E there, that'll help remind you what that means. It's an ethyl group. And even though this number's bigger, you start in alphabetical order with E for ethyl. Then, where is your other derivative located? On the second carbon. And that derivative is called what? When you put that letter there, it helps you decipher what it actually is. Which is M means what? Methyl group. Okay. Running out of space here, but 4-ethyl, 2-methyl heptane.
Wouldn't it be diethyl because there are 2 ethyls?
No, because this is a methyl group and that's an ethyl group. They'd have to be the same one to do that. The question was, wouldn't it be diethyl? No, that's only if you have another methyl group, it would be dimethyl, or if you had another ethyl group, it would be diethyl. Okay, we're running a little long here, so we'll talk about this one tomorrow. Is there anything you'd like to ask? So left outside and left middle, we're good. Middle and right side. Okay, so very quickly you could work backwards. What does ANE mean? Everything's single bonded. What does HEPT mean? And there's 7 carbons. What does a methyl group mean? CH3, there it is. What does that tell you? It's on the second carbon. What does an ethyl group mean? C2H5, there's an ethyl group. What does the 4 tell you? It's on the 4th carbon. Tells you where it's located. All right, so we're about to hand this paper out, and the rest of the time will be yours, so we'll catch up to you next time.